these are square numbers: 0, 1, 4, 9, 16, 25, 36, 49, 64, 81 and 100. These are the squares of numbers from 0 to 10, and everyone knows them by heart. But have any of you noticed a certain pattern that is there in these square numbers? Well, thinking hard enough, I guess what someone would do to find any pattern between any sequence of numbers is to find the differences between consecutive numbers. We'll try that. 1 is the difference here, 3 is the difference here, 5 is the difference here, and 7 is the difference here, and hopefully you're getting the pattern. 1, 3, 5, 7. What are they? They're odd numbers. So is it that the differences between square numbers always follow odd numbers? We'll check. 25 minus 16, it's 9. 36 minus 25 is 11. 49 minus 36 is 13. And so on. The differences between consecutive squares are consecutive odd numbers. And the differences between consecutive odd numbers are 2. They have a constant difference. So this pattern exists no matter what square you take. And now, how can we figure out the differences between two consecutive squares for any number x? I haven't told you. Something like 45 square minus 44 square. How do I figure out? Well, we'll look at this thing. The difference between the square of 1 and 0 is just 1. And then every other difference is simply adding 2 to this initial difference. So 5 squared minus 4 squared is 1 plus 2 plus 2 plus 2 plus 2. So it's 2 times 4 because I'm going from 0 to 4. Like I'm looking for 5 squared minus 4 squared, right? 1 square minus 0 square. I'm moving 4 steps away. So 4 2's are added, or 4 times 2 is added to the initial difference between 1 square and 0 square, or 1. So the difference, or the answer, the result of x plus 1 whole square minus x square is going to be 2 times x plus 1. So this result we get from our intuition, if provided this pattern is consistently followed. We've till now come up with no proof for why this pattern is consistently followed, except that any square we take, like we'll take something like 24 square minus 25 square minus 24 square. 25 square is 625, and 24 square I happen to know it's 576, and the difference is 600 minus 576 is 24, plus 25 it's 49. So again this is, and by the way this is a Pythagorean triplet. It's 24 square plus 7 square is 25 square. So even this is an odd number, and presumably it's the 24th odd number. Yes, it's 1 plus 2 times 24. It is 1 plus 48, 49. We'll go on to show that this is a consequence of the formula a plus b whole square is a square plus b square plus 2ab. So according to that formula, we'll expand this x plus 1 whole square term. It's going to be x square plus 2x plus 1 minus x square, and indeed the x squares cancel, leaving 2x plus 1. So it is a consequence of this thing, and we'll also think about this result for a while. The difference between two consecutive squares being 2x plus 1, this should seem kind of familiar, not just because it's the formula for generating odd numbers, but also because 2x here is the derivative of something, and it's the derivative of x squared itself. So the amount by which x squared changes should be 2x for a unit change, but it's 2x plus 1. So why is it so? Well, that's because the instantaneous rate of change of x squared is 2x, and the change in x squared for a unit change in x is not instantaneous, it's a macroscopic change. But anything macroscopic can be explained in terms of other smaller microscopic quantities, like the air in this room can be expressed in kinetic theory using the individual molecules of air, which is a conversion from microscopic properties to macroscopic properties. So the total change in x square as x increases by 1 is 2x plus 1, and the microscopic changes in x square as x increases microscopically is 2x times that tiny change. So this total change should be the sum of all of those tiny changes, and we'll see if that's true. So now we'll write down the expression, the sum of all of those tiny changes, which is as x square, the function x square goes from x to x plus 1, is going to be 2x dx, which is the tiny change in x square from x plus dx to x plus dx. So this is 2x dx, and then we want the change in x plus dx square. So that's going to be 2 twice of x plus dx times dx. And now we're going to take the next change. It's going to be 2 times x plus 2 dx times dx. And this goes on. This pattern continues till x plus n dx times dx, where n is 1 by dx, because we have to go from dx equals 0, so to speak, till dx equals, from this value x equals x, from this value to be equal to x plus 1. So that's how far we have to go, and this sum should be equal to 2x plus 1 if we are any right. So, but this is not actually the sum, because we can't take dx equals half or quarter or something like that. It won't be equal, because this is the instantaneous rate of change. So this is not the sum. The sum of this is not 2x plus 1 until and unless dx in all of these cases is 0, or this is equal only when the limit as dx approaches 0. And how many terms are there here? The number of terms. Number of terms is 1 by dx. So as 1 by dx approaches infinity and dx approaches 0, this equality will hold. Now how do we confirm it? We'll confirm it like this. First, and I'll go on to independently handle the LHS and show that it is equal to the RHS. So we'll remove this for now, and then over here we'll take 2 dx out of this entire expression. So how much will this be? Two dx times, and now all the individual terms, x plus dx plus x plus 2 dx, and so on. And now the way I'm going to find the sum, and it's not, doesn't go to infinity, by the way, kind of it stops at x plus n dx, but anyways the number of terms is going to go to infinity, so it's fine. So what is this sum equal to? Now, as probably all of you know, the sum of certain terms divided by the number of terms is the average of all of those terms which are there. So the average of those terms times the number of terms should be this sum. So I'll take this average and multiply it by the number of terms. How many terms are here? It's infinity, but what's the average of all of these terms? The average of all of these terms as x goes from x to x plus 1, and all of these intervals are evenly spaced, and hence the average of this is going to be in the middle of x and x plus 1. In other words, the average of all of these terms is going to be x plus half, and the sum of all of these terms is going to be x plus half times 1 by dx, because 1 by dx is the number of terms. So now we've got this thing. It's 2 times dx times x plus half times 1 by dx. Dx and dx cancel, and 2 times x plus half is 2x plus 1, and we've got it, which is equal to the RHS. Even though this should be obvious, it's kind of interesting to derive it in this way, and at least for me, I guess. And now next thing we'll do is think more about the fact that why 2x is the derivative of x squared. Like obviously you all learnt it in calculus classes, but is there another way which has to do with these consecutive differences? Well, there is. X plus 1 whole square minus x square, as in a macroscopic change as x increased by 1 unit, is 2x plus 1. But what is this? As x decreases by 1 unit, what's the change? Well, you can work this out, but it's going to be 2x minus 1. And the average of these two is 2x. So the average of the forward change and the backward change is 2x. Or in other words, the derivative at that point. So this is really curious and fascinating. And we don't as of now really know why, but then we'll go to check if this holds for some other functions also. So we'll take the function x squared plus 2x. Now how much will this be at x plus a? Like this function evaluated at x plus a. And the function evaluated at x minus, or like just x plus 1. So x plus 1 whole square plus 2x plus 1 minus x minus 1 whole square minus 2x minus 1 divided by 2, or the average of these two changes. So this one is going to be, as I showed, it's going to be 4x, this one, and these things, the average of these two is going to be just 2 times 1 minus 2 times minus 1. So it's going to be 4. So it's 4x plus 4 by 2. So 4x plus 4 by 2, or in other words, this is equal to 2x plus 2, and 2x plus 2 is the derivative of x squared plus 2x. So this does seem to hold. And well, it does seem to hold for all expressions whose derivatives are linear equations. And we'll make this conjecture now, that for all functions whose derivatives are linear, this thing will hold. Its derivative is going to be the average of the forward change and the backward change. So how do we prove this now? Well, I guess all of you are familiar with the fact that areas under graphs can correspond to integration of functions, and differentiating a function and then integrating it back again will give that function. So now what I'm going to do is I'm going to graph the derivative of a function, and this we are constraining it to be a linear equation, as we've told, and this is x. Now since it's a linear equation, it will be a straight line, and what we want to show is, I'll write it in its broadest form, f of x plus a minus f of x minus a divided by 2a is the derivative of f of x. So we have to prove this. Now we'll take this point x, and then we'll take this interval to be a, and this is x minus a, and this is x plus a. I'll rub this one up. So f of x plus a, this is by the way the derivative of f of x. So this is not the graph of f of x. F of x plus a minus f of x minus a is, according to integral calculus, the area over here. This area is f of x plus a minus f of x minus a, and now we're dividing it by 2a. So 2a is this distance. It's 2a. So this area divided by its width is going to be the average height of this graph, of this shape. So what is the average height? At x minus a, the height is its lowest, and at x plus a, its height is the highest. So the middle height or the average height is the height it has at the midpoint of this line segment, and that is at x. So you just draw a line, and sorry, this is not the midpoint. I mean, it doesn't look like the midpoint, but that's my intention. I want x to be in the middle of x minus a and x plus. So this height is the average height of the shape, and what is this height equal to? Since we are graphing the derivative of f of x, this height is the derivative at this point. So indeed, our conjecture has been proved in this way. So thank you for watching. I hope you enjoyed this video. Thank you.